Hi, welcome back to our first example for 5.3. In this example, we are going to look at a function in the form y equals a sine kx. So a is a parameter that changes the amplitude, and k is a parameter that changes the period. Okay. So we're given this function here, and we're asked for the amplitude, the period, and then they want us to know how many cycles are going to occur from 0 to 360. And lastly, graph the function. Okay. Sometimes it helps to even graph the function first and then try to answer these questions. Okay, I'm just going to give us a general formula that is actually going to help us with all these examples that we're going to do. And I'm going to kind of color code things a bit too. Okay, so we have a basic sine function, and then we have those parameters that are being introduced to it. So you're each going to have some kind of effect. So it's kind of easy to remember these. A always gives us the amplitude for the function. Okay, so if A is a large number, it's going to be a big amplitude. If it's small, it's going to have a small amplitude. Also, if it's negative, it's going to reflect the graph along the x-axis. We also have K. K is not the period. What it does is it actually just affects the period. Okay, so as K increases, we actually compress the graph and the period gets a little bit smaller. And then D, so we would have seen these from the investigation. D does a horizontal shift. Okay, you're going to see a little bit later in other sections, we actually call this a phase shift. Okay, so when the graph just slides over so many degrees, it's called the phase shift. And then C is our vertical shift. Now, what I like to call it is I like to call it the center line. Okay, call it the center line because C actually shows us where this imaginary middle line would occur. That'll be the middle of our graph. So if there is a vertical shift, then that center line moves up and the whole graph moves up with it. Okay, so let's go to this example and let's answer a few things. So if we kind of compare this to here, we can see we have A equal to 3. Therefore, amplitude is 3. Now our K is equal to 4. So what do we do with that? Okay. Well, there is a formula for finding the period. I'm going to add it up here. The period is going to be 360 divided by K. That's how we can find the period of the function. So notice when K is 1, that's not a horizontal transformation because it's 1, it stays the same. And the period is 360 because you'd have 360 divided by 1. If we increase this to 2, then the period would be 360 divided by 2, and it would give us 180. Let's double check with our Desmos app to make sure that's what actually happens. So I'm just going to reset these. Okay, so this is a cos graph on here because I switched it to cos in the last video. But either way, it's the same thing. So what we're going to do is we're going to change K to 2. And let's see how it compares with the other graph. If I increase K to 2, notice the red graph. There's actually 2 cycles within 1 cycle of the blue graph. So the blue graph starts at a maximum of 1. The y-intercept is 1. And then at 360, it's back up at 1. But notice the red graph actually does 2 full cycles. So what it does is it actually changes the period by a half. Okay, so if you divide the period 360 by 2, you get 180. A really good way of remembering what K does is this number 2 here tells us the number of cycles within 360. So right now there's 2. If I change it to 3, that's 33. If I change it to 3, now we have 3 cycles within 360. Okay, if I change it to 5, there's going to be 5 cycles now. Okay. Notice if I change this to a half, now there's only a half a cycle within 360. Okay, so that's one way to remember what K does. It actually tells us the number of cycles within 360, and it lets us know how the period is going to change. So if K is equal to 4, then the period is going to be 360 divided by K, which is 360 divided by 4, which is 90 degrees. So that means the period is really small. It's normally 360, now it's 90. Okay, the next question says, how many cycles will occur from 0 to 360? Well, we know that 4 cycles are going to fit now because the K value is 4. So we could say 4 cycles. 4 cycles of the graph will fit. Graph the function from 0 to 360. So knowing these things is really going to help us to generate a basic graph. Okay, and I'll mark off 360 here. Okay, I'm going to cut this in half, about right there. That's 180. Cut this in half, that's 90. In half there, that's 270. Okay, so we now have 4 sections. I am actually going to have 1 full cycle within each section. Okay, I drew that a little bit funny, but there'll be 4 full cycles. Okay, the amplitude is 3. So what this means is I should have a maximum value up here of 3 and a minimum value down here of -3. If you remember, sine graphs start at the origin and then work their way up. So I'll show the basic sine graph first in black. Starts at the origin and works its way up. So it normally would go to 1, back to 0, down to -1 over here, and then back to 0. So this is the basic sine graph. Okay, that looks a little bit funny, that last part. Let me fix that. That's my point up there. Okay, so that's the basic sine graph. Okay, now this one, the amplitude is now 3, and there's 4 cycles within 360. So we have a point up here, point down there. So my new graph, which is this one here, I'm going to draw this in green. It now has an amplitude of 3, so it has to go all the way up to 3 and then come back. Okay, now that's if there's 1 full cycle within 360. So the problem is that we need to have 4 cycles within here. So we're going to have many cycles here. So our sine graph starts at 0. It's going to go up to the top, then back at the middle, halfway, and then down, and then back at 90. So let's chop this 90 section into quarters. So we need to go up to the top, back to the center line or the middle, and then back down to -3, and then back to the origin. So this is 1 full cycle. That's how I get 1 full graph within 90. We always got to start at the x-axis or the origin, go up to a maximum, back to the x-axis, then down to a minimum, and then back to the x-axis. That's one full cycle. Okay, now I just need to repeat this 3 more times. So what I do is I chop up each one into quarters. We don't need to label them. So we got max, middle, minimum, middle. That's the pattern for drawing these. So at the middle, we go to a max, back to the middle, down to the minimum, and then back to the middle again. And we're going to do that one more time. Back up to a maximum, to the middle, to a minimum, and then back to the middle again. And that's my 4 graphs, 4 full cycles of the sine function. And they all have an amplitude of 3. If it helps you, you can draw some nice dashed lines through here to show your maximum and minimum. Okay, so this first example shows us how to handle the 2 parameters, the amplitude and changing the period. Okay, that's it for this first video. I'll see you guys for the first example. I'll see you guys in the next video.